We are live. And we got those sweet sounds of the 3D printers in the background because once again, one of my prints failed. So frustrating, but this one was entirely my fault. I actually, 26 minutes into the print, ran out of filament. So, yeah, and then I didn't come back and check it. Came back this morning expecting a big build plate full of all the parts that we need for today. Turns out they weren't there. So the first thing we're gonna do is throw a couple more things on the printer. So first things first, we need more of these bars right here. These pieces right here. So I have 6 in here. I can show you what's printing right now in the meantime. So we got a big gear printing on the Prusa right here. We got these 3 guys are finished. Let's pull these off the bed first and foremost. Amazing. And we can put a couple more to print on there. So let's get those pieces in there. And I think what we'll do is maybe we're gonna print one on this printer. And we're gonna print, because this is, I believe, is a half-hour print. Yep, let's grab the USB stick. Oh dear. Oh look, the other one's done, so we can print that as well. Let's grab that USB stick. It's actually a memory card, my bad. Okay, so yeah, I guess I'm kind of out of USB ports here right now. I guess I can unplug this. So in a half hour, we are gonna have all the pieces we need for iteration number 2. It's the second iteration of this, and we'll get to it in a second. Let me just get this on the printer right here. Replace, yes. We need to print on this printer, the next one. Prepare to print. Unplug this. This is the system we got going here. Not very efficient, but it's all right. All right. Save this. Beautiful. Let's get these on the printer. Yeah, I'll take you guys with me. So it should be a half hour before these parts are done, but we got other stuff to do in the meantime, so don't worry, everyone. Beautiful. All right, so bring it back. Get rid of this. Good to go. Okay, so last night, or yesterday afternoon after the stream, we're gonna make this bigger here so you guys can see what we're doing. So, someone on the stream yesterday suggested why not do an articulating arm instead of little dangling weights? So these are, let me pull open the first iteration. So the first iteration, we have dangling weights, and I actually took apart everything that we did yesterday because I think it would be better to do the whole thing. So we're going to test all 15 dangling weights, and then we're going to test the second iteration. And I'll show you the difference between the two if I could find it. This one right here. And I can tell you what I changed as well. So this is the first iteration right here. There's 15 arms. There's going to be 15 of these weights dangling from strings. One of the problems that I was running into is when you crank it, if you're not like really steady with your hands, it starts shaking, and then all the weights start shaking as well, and it just doesn't look that good. So like I was kind of like feeling a little defeated yesterday. I was just like, you know what, this project is just like not gonna work. You win some, you lose some. It's just the way it goes. But someone suggested why not use an articulating arm system, and so I decided to mock it up, and I'll show you this here. This is the mock-up of the articulating arm system. I think we need one more C-clamp up in here. And this has its advantages because, I'll pull you guys in and I can explain this to you. So this is the articulating arm system, and basically each one of these arms is in one of these slots right here. And as the strings are going to move up and down, the whole arm system is going to be moving like this. And this has the advantage of being a lot more obvious. The waveform that we're trying to create with the strings is going to be a lot more obvious. Another advantage of this system is that I think you're not going to need as many in order to get the same effect. So that's why I went from 15 of these articulating arms down to 9. And it just looks a lot cleaner. I was able to get this gear to fit in a lot more nicely. And also, we're going to switch from, we have this gear ratio right here on the crank, and we were just finding that it was a little too slow. So we're switching from this gear ratio, we're going to crank this gear, which I realized actually last night while I was trying to go to sleep, that this gear does not need to be here anymore. So this was a mistake, but it's all good because it's still going to work and it looks cool. Although in the final version, we're probably going to get rid of this gear because it's not attached to anything. It's just this bevel gear that's important right here. Oh, you guys can't see my screen. It's just this gear right here is completely redundant at this point. See, it's not attached to anything. It's just bevel gear that's important. So yeah, so that's the difference. So we took out this gear right here. We're going to make the whole system work a little bit more quickly, and then we're also reducing it to 9 arms and an articulating wave system like this. And I actually set this up so you can kind of see how it works. So as this rotates, the arm system is going to articulate like that. And that should give us a cleaner effect. I think it's actually a little bit cooler than the weights. But that being said, we're going to put the weights together, the whole thing, all 15 weights, because they're all available and ready to go. And then we can make a comparison between the two once the parts are done printing. So let's grab all that stuff and then we can get going. So everything is right here on my desk. We're going to bring it over to this table right here. We can work on it here. Turn you back around because this is where we're going to be working today. I'm going to make some room here. Things got a little crazy. As they tend to get when I'm working, I tend to just create a tornado. Thank you, Jose. I appreciate it. I plan to. So this is what I was talking about here. See how slow this gear moves? So what we're going to do is take out this gear ratio right here, and that's going to make things move a lot faster. So let's start putting it together. Gotta get our weights. And you can get this out of the way for now. Gotta let me know if the volume's okay, if the sound's okay. I know there's a lot of sound coming from the 3D printers. They're just over there. But yeah, there's nothing I can really do about that. I just really wanted to get this piece done on stream today for you guys, so I had to finish those prints. And to save you guys the pain, I ended up doing all these strings already. So we're basically like good to go at this point. We're just gonna have to, oh, let's just do it. We're just gonna put this here. That comes on there. And I'm gonna bring you guys closer in so you can get a better view of everything going on here. So this part's a little tricky, but this whole system right here is going to lock into the base. And hopefully we're not going to tangle any wires here. That's one leg down. It's okay, we can fix that after. Lots of these fishing wires. Okay, there we go. We'll just get it lined up for now. It's good enough. This last piece in. So if you guys have any questions, comments, anything at all, feel free to chat with me here while I'm doing this. I can do both at the same time, kind of. Alright, so that pushes in like that. So now we have the fun task of getting all of these strings wired up. I think we're going to go... tweezers. So once we got one in, we can kind of just go from there. And I think we're just going to do this one to this hole right here. I'm gonna try really hard not to tangle anything up. This is gonna be quite a challenge. Boom, got one. Fuck yeah. So these go through these holes right here. They come up through this right here. And then they come out like this. So, in order to figure out, you know what, let's first string all these up and then we can hang the weights. I think that'll be fine. We won't lose them. So the key right here is, I don't know if you can see this. Yeah, you can kind of see. So each one of these strings corresponds to each one of these, I call them trunk pieces in the CAD. And basically this string holder thingy will hold this orientation relative to these branch pieces. So as this big gear rotates, this will always be kind of like in line with this. So now we gotta just get all the other ones lined up as well. And I just gotta make sure I don't mess it up. So this will then go into this next one here. It's a little bit, I just forgot the word for tasks like this. Annoying, one way to call it. Just like dealing with fishing line is kind of a pain in the butt. So if anyone knows who Ruben Margolin is, he is the inspiration for this piece. His works use like tons of different strings, and I can only imagine what it's like putting that together. But this is art, right? This is the part where it's like, you gotta sometimes make those sacrifices for the sake of the art. Like, you know, if you're making a painting and like you're using a style where it uses a whole bunch of different brush strokes, like small brush strokes, like it takes a long time and it just is what it is. But the desired effect is worth all of the work that you put in. Just gotta make sure I'm getting everything lined up in the right positions. That's key for this to work properly. Boom. It's 3 down, 12 to go. Maybe I'm gonna tape them into place. I think that's a way to contain everything. Yeah. Yeah. So, just so you guys know what I'm working on, for all of you newcomers to the stream, pull this open right here, display capture, we're going to put this in the corner, put it up top. So this is it right here. This is the sculpture and it's all its glory right here. So we're just stringing these strings through the whole system here, and if you bear with me, it's going to make a lot of sense where this is going, and it should look pretty cool. Like yesterday, we did, I think, 9 strings, and it was pretty promising effect. So I'm excited to see what these all 15 look like when it's all said and done here. Boom. This is very tedious. That's the word I was looking for. Tedious. Yes. Just had to let my subconscious work on it for a while. It's kind of like, you know, like when you like are at a party and you like want to show someone. Like I was at a Halloween party on the weekend and someone was like, "Yo, you gotta see what I wore last year for Halloween," and then they just spent like 6 minutes looking for the picture of their last year's Halloween costume. By the time they finally found it, it was like we were talking about something completely different. And they're like, "Oh, here it is." That's kind of like what the subconscious does when you can't think of a word. Come on. There you go. Next one. This blue guy right here. So yesterday I tried to like alternate the color of the rope here, and yeah, today I was just like, screw that, we're just gonna get them tied in. I actually got really good at tying these knots by the end of it because I did 2 of these, and it's because the other iteration also has one. The other iteration is gonna be a little easier because we can string the branch pieces and then put the rope and then put them into the base, but for now, this is the best way to do this one, I think. Yeah, it's patience that I don't even really have, but, you know, sometimes the motivation of, like, trying to get something to work trumps the level of patience that you have, and this is a perfect situation, a perfect example of that kind of stuff. Because, yeah, generally speaking, I don't have patience. I'm always working with, like, a little bit of, like, fervor. And that's actually something I'm trying to learn to improve on, because I find like I just read a book. It was a really interesting book. It talks about like It's called The Practicing Mind, and it talks about like, you know, like getting lost in the process of something rather than like the outcome. So this is one of those situations where like I really just need to like, you know, like feel present in just, you know, stringing strings, I guess, and not worry about like how long it's taking or like, you know, if it's gonna work, because, you know, generally speaking, a lot of this stuff is all just trial and error. And, you know, I've never done a string project before, so I'm just learning and trying things, and yeah. So get lost in the process, be present. These are all the things I'm working on right now. Trying to figure out how to be patient. Luckily, patience is something that can be learned. And I wasn't born with like high levels of patience, that's for sure. Something I'm continually trying to learn. Continually trying to work on. Often failing. But that's just the way it goes, right? Okay, so that was this one. Now we need this one here. I did a workout this morning and it literally hurt the entire time. I woke up, I was like, I do not want to do a workout today. And honestly, just like, it was just one of those workouts that was just like so hard to get through. But this is another thing that I've been like really like trying to like learn lately, is that anything and everything just like eventually comes to an end. It's always transient. No matter how much it hurts, no matter how good it feels, it always comes to an end. When it hurts, obviously it feels like it comes to an end a lot less quickly than when it feels good. But yeah, so no matter how much even a workout hurts, it's always eventually going to end. And that's just something that like has really been helping me get through things lately. So even this process of stringing these strings through this hole is eventually going to come to an end. And we're going to have something, I'm not sure what, can't promise anything, but we will have something. And I thank you guys for hanging with me while I do this. This is a lot of fun. But yeah, like take this moment. I'm just stringing strings here. So if you guys have any questions about what I do, any questions about engineering, any questions about life, questions about anything, comments, doesn't have to be questions. Comments, if you have any opinions on what I'm talking about, yeah, definitely I would love to hear you guys. Love to hear what you guys have to say. Also, like when life gets small, get tweezers. That's my last bit of wisdom I'm gonna feed you guys with today. When you're doing things that are small, you need small digits. Okay, we're almost there. Yeah, we're almost there. Get some of that yaw in me. Thanks, Tobias. Yeah, you know, it really comes a lot more from motivation to see it work. It actually is impatience to see something working. That's where I get the patience. It's like kind of ironic. Because generally speaking, when I design something, when I have an idea for something, I need to get it out as fast as possible before I like get over it. So maybe it's not patience. Maybe there's something else there. A little less healthy. I do enjoy the process of engineering, so that definitely helps. Definitely helps me to get through the different iterations that are necessary. But sometimes it gets a little like stressful, you know, like I do often find myself in these situations where I'm like, oh, it's never gonna work and there's nothing I can do, and then like, you know, sometimes like after like sitting with it for a couple hours, you just like come up with a solution. You're like, oh, like why was I all doom and gloom like 2 hours ago? Stupid. But at this point in this project, I'm at a point where I just like want to get it done because I want to move on to the next project. I'm so excited to do that. I really like starting projects and I really like end results. And I guess what I was talking about earlier is like the whole patience thing. Like that's where I'm learning to just enjoy the middle part of projects. But it's funny, I tend to go through this like very, very like repeatable cycle where it's just like, you know, I start and I'm really excited about a project, and then I get to this point where it's just like I hate everything there is about the project. Yeah, the rounded corners is definitely an extra step, but that is that's the art side of the engineering that I do. I'm building this. I'm in Canada, in Toronto, if that's what you mean. And I'm actually like, this is just a room in my apartment that I live in here with my girlfriend. Close to the downtown core of Toronto. It's a really beautiful city if you've never been. How about you? Where are you from? All right, look at that. 3 more. Never thought this moment would come. Did I mess anything up? What did I mess up? Oh no. Oh no. I missed this guy right here. So this one. Okay, I only have to redo 2 of them. Okay, we're gonna work backwards from this guy here, just so we don't mess it up anymore. I think I'm starting to get this like method down. Definitely getting easier and easier. Nice. So I tricked you guys. There's not 2 more because I messed 2 up, so there's like 3 more. 4 more maybe. Looks kind of cool though right now as it stands. Just the string just like all looping around like that. It's pretty nice. Steven, 3D Printer Academy, Steven. His name is Ruben Margolin. And if you look him up on Instagram, his stuff is incredible. Actually, I'll just show you guys. Because like I like have had his Instagram page open for a while. Let's it's right here. Amazing. So like this piece right here, especially like this is where I like kind of got inspired for these articulate. Well, someone actually mentioned articulating arms, and then this is where I went to figure out how to maybe best design them. This piece right here is like, look at this. Jamie, I'm a SolidWorks guy. I've been using it for like 15 years, but as I mentioned often in these streams, all CAD softwares are pretty much the same. So once you learn one, you can use others, and so I don't have any specific recommendation of one over the other. I just know how to use SolidWorks, which is why that's the one I use. But I recommend any CAD software that you can actually like get a copy of and use, because like at the end of the day, SolidWorks is great, but it's not the easiest software to obtain. It's not the cheapest software. Okay, this guy right here has to come out and through this hole. But yeah, there are some free CAD softwares out there, and like if you're just trying to learning on any of those free CAD softwares will teach you all the skills that you need, and then you can take them and transition them. One thing to keep in mind though is there's different types of computer automated design. So there's a software called Blender, for example, and that uses triangles basically to do the design. So it's different from SolidWorks or Fusion. They're kind of the same, where you're using dimensions. It's parametric, it's called. And everything is based off of sketches and stuff like that. And what that does is it allows you to like create like engineered pieces, which are different from the stuff that you might create on Blender, which is more like artistic. That's the best way I can describe it. So yeah, if you're trying to learn parametric software, make sure that you're using a parametric CAD package, which there are free versions, and I'm not exactly sure. I know there's like Onshape and there's like, you know, stuff like that. There's SketchUp was always good, but I don't know if it still exists even. Maybe it does. Do you already have a software that you use, that you prefer? Are you a Fusion guy? One of my good friends is like probably one of the best engineers I know. He uses Fusion. He's really good with it. So it's really just a matter of familiarity. Okay. Last one. Yes. And then we gotta hang some of these weights here. Sweet. Wow, that feels amazing. Yeah, it's probably true actually. I don't know. You know a lot more about Blender than I do, so you would know way better than me. But yeah, look at this. I love the way all these strings are hanging in. That's like good enough on its own right there. But let's hang some weights. So I'm going to show you basics of the way the weights work. And it's easier to show you in the CAD. So let's just make this bigger. So basically, we're going to go back to the original. And then I actually just learned this, this new mate, which is really cool. So let's just make sure this is all lined up first. Yeah, I actually had that problem as well. SolidWorks does offer this, it's like, what I'm using right here is, see how it says like the student version down here? It's like the academic version or like the hobby version. So you might be able to get a hobby version of SolidWorks. and that can overcome the problem. And this is really just like the normal version. The only weird thing it does is it puts these like, I don't know, these like graduation caps next to all of the parts, and it says like when you export a drawing that it's from an academic version of SOLIDWORKS, but otherwise everything's working great. So yeah, definitely an option. Okay, let's oh yes, our parts are almost done actually. But I'm going to just show you based on this right here. So see this guy right here? As this rotates, this gear will rotate. This piece right here doesn't rotate. See, as I rotate it, it keeps its orientation. And that's because the strings are going to be holding it in place. So what I can do is I can create a mate here, which I just learned about this the other day. First I gotta figure out why this isn't lined up right. So I think we're just aligned with the wrong mate. It's this one right here. Let's flip this. Boom, that's better. So what we can do with this mate is we can use a linear coupler mate. I'm gonna just couple this face to this face. And I might need to reverse it, but we'll see. And so as this rotates, yeah. So I just need to reverse it. So bear with me for a second. Reverse. So you can see as this rotates, the weight moves down and up. And the reason for that is because the string, which is going to be coming through here, not this guy. Hey Tomas, welcome to the stream. So the string is going to be coming from this hole, through this hole, up through here, and around and down to this weight. So when it goes to this position, it's pulling the string. This is going to be at its highest point. And when it goes to this position, it lets the string out, and it's going to go to this point. So we got to basically align all of these weights here to the right spot. And the best way to do it, so right now you can see, I'm going to go back down. And I'm going to come down here, a little bit lower, give you guys a better perspective. And I actually made a tool to help me with that. Let me grab that tool. Where'd it go? So basically we're going to start where the string is at its longest, which is like right here. And then this will go to here, maybe right there. And then when the string is at its longest, I'm going to use these wedges right here. I'm going to wrap the string on the wedge. Use this tool for spacing. Boom. And then I'm going to jam this in. Like that. Boom. And hopefully, that means every time I do that on all sides, that's going to be at its proper height. I'm not going to cut this excess yet, because I just want to make sure that it's all right first. Let me give you a little bit better view. There you go. Like maybe we need to get some more light up in here. I'm gonna get you guys some more light. It'll make this a little bit easier to see and just more generally better. Which light are we gonna use? This one. Alright, let there be light. Oh. Yeah, let there be light. And also, let there be less sound. Oh my god, it's so nice to have those printers off. Amazing. So much better. Oh, the last print's done. Oh. Wow, I can actually hear the music again. All right, let's finish this so that we can do the next iteration. Suggested by a stream viewer. All right, so we basically got to now do another repeating of the process a whole bunch of times. So I set the string holder majigger, the string mount I think it's called, to the furthest position. Now we're gonna grab, I don't know what this music is. Let's put on something a little bit more chill. I chose In the Garage playlist, and it's pretty intense. How about graffiti and street art playlist? Let's see what this is. Hip hop and lo-fi beats. I like that better. Okay, so this goes here. Maybe let's just stay there. Yeah, amazing. You can see what I'm doing. So now we're going to wrap the string around this wedge. I gotta find the best method, but for now, this is what we're doing. Jam this in here, like that. Oh, nice. Okay, that might be the move. And then we just keep going. So, jam. Wedge. I'll give you a better view on the next one. Push it into place. Beautiful. Here. I bring you like this. Thomas, there's like, it's been a huge pain in the butt to make sure they don't get tangled, but, oh, you know what I forgot to do there? That's actually wrong. Got carried away. So I forgot to get the string aligned first before doing that. But yeah, once everything's in place, they shouldn't get tangled just because of the way it all runs through the system. So let's do this one more time. This is all part of the process of like building your own things for the first time. Is like I tend to make mistakes. But look at that, I'm already getting better at it. We're learning a skill here. Next. So align. Jam this in. Grab a wedge. Hold it in place. Grab a wedge. Pure focus. Oh my God. Grab a wedge, hold it in place, grab a ornament thing, push it onto string. All right, so just need to switch hands. Okay. Next. You can see like what I'm doing here to align. So basically I'm just trying to get this string right here to be at its longest point before dropping the ornament. So now that that's there, come back, jam this on. So this is actually like a piece I printed. I 3D printed that to help me with this assembly process. So that's actually always like a fun thing to do. Hello, Dwayne. Welcome to the stream once again. But yeah, it's always fun to like, you know, like use 3D printing to like create little tools for yourself, which like this was CADed directly onto the design, so it fits perfectly. Look at that. Oh, that one already has. I'm actually getting, oh, spoke too soon. So I would definitely find ways to improve this tool, but for now it's working better. It's better than the system we were using yesterday, which was like a very vague measurement. So yeah, every day is just a little bit better. So as you can see, actually you can already kind of see it. Do you see how each one of these weights is at a different height now? And that's kind of the, like that's the wave coming together, which is really sick. Love that. This is the best part. This is the best part is when you see all this work, you know, starting from the original prototype to like days of CAD. Yeah. Does anyone have any ideas for like what these look like? I decided to keep them like sort of vague on purpose. Sort of like abstract, because like I don't really like to say any direct statements with the work that I'm doing. This one's tight for some reason. But it should work fine. Perfect. Yeah. Oh, you know what? I did it again, didn't I? Damn it, Jay. Get your shit together. Obviously, it's like the tight one that I have to undo. Oh, it's not gonna go. Okay. There's a solution. Comes in the form of a flathead screwdriver. Try to wedge this thing out. That's not gonna work. We need a smaller flathead. Smaller guy. This is definitely something I need to remember the next time I do a wedge design on the next iteration, is there needs to be a way to get them out without fucking everything up. Screwing everything up. Sorry, guys. I think what I would just do is put a bigger bevel on this hole right here. And that way you can really jam something in there and pull it out. We almost got it here. Okay, let's do that again. We need to get this into its proper position first. And that is right there. Ish. Right there. Yeah. So the tweezers would actually, I have tweezers, but they would just bend if you put any force on them. So that's why I'm using these screwdrivers, because these really get the job done. Let's keep going. So jam, wedge. Try a new approach here. Push it down. Boom. Next. And look at that, I actually remembered to set the string before I start. About there. It definitely is, it's testing my patience, this kind of stuff. Doing the same thing over and over and over again. If any of you saw the FlingBot video, making those valves, I had to make 12 of them. And that was purely by my own choice. When I say I had to make 12 of them, I should be saying more like I chose to make 12 of them. But that really tested my patience. This is frustrating. I do not have any other fabrication machines. I'm heavily considering to buying a CNC right now. That way I can do some other stuff with other materials. I really want to work with some metals. Yeah, right now like 3D printers are like the cheapest form of manufacturing equipment that you could get. Surprisingly, it's very interesting because 5 years ago they just started becoming like more available. CNCs have been around for a very long time, but it's only been like really 10 years since you could have your own desktop 3D printer, and only 5 years since they've been like really like good enough that like you can just like anyone can do it. But yeah, 3D printers I've got 4 of them. So I have a lot of 3D printing capability, but there's only so much you can do with FDM printers. I was thinking about getting a resin printer as well, but I think for like right now, the best thing for me is to have a CNC. And I actually have some experience with CNCs, so the learning curve won't be that big, luckily. The only problem is, like I mentioned a little bit earlier, I'm working out of my apartment, so CNCs can get a little messy, so I'd have to like really consider like dust collection and also space is a huge consideration as well. But I think I can rearrange things in this room and make it possible. Might be pushing it a little bit. My girlfriend's probably gonna be, she's so accommodating, so she's gonna have to be really accommodating of a CNC as well. But it will definitely I'll be able to up my game by adding some subtractive manufacturing. Boom. Oh, never mind. We're good. I thought I didn't line the strings up first, but we are good. Luckily, the next one that we make will be a little bit easier. And I actually just remembered I have to print one last bit of parts. I've looked at the laser at the Glowforge, and it's actually a really, really great machine. I worked with it at my last job, but I think for the sake of there's one small problem with the laser cutter is the laser cutter, the edges aren't perfectly straight. And I do a lot of stuff that requires precision, like these gears and stuff. And I want something that can give me that precision right now. That's more of what I'm interested in looking at. And then the other thing is like being able to cut metal is very, very key. Like the last YouTube video that I posted was a video of a paper airplane launcher, and that was where I was like really feeling like I needed some material other than PLA or ABS, but some other material other than something that's just being like FDM printed. Jake, I have a little bit of experience with Blender, not tons. I got into it like maybe like a year and a half ago, just to try to make some like sculpts and stuff like that. I've done some hands, I've done some like funny little like faces and stuff like that. But let me see if I have any examples of the stuff I made on Blender. I don't even know what it would be. It's been so long. Sculpts. Let's see what this looks like. Oh. Let's see. I'm opening it in Paint 3D. Apparently, I'm not actually. Here, let's look at it like this. So, I made this guy on Blender. It's creepy, like, inspired by a scary movie. Any of you guys remember the, like, funky aliens? The kick in the nuts aliens? But yeah, that's about as far as my Blender went. I actually do plan to like pick it back up again because I have some ideas for some stuff that I want to make. But yeah, it just takes a lot of patience, and like right now, I guess I'm, time is a finite asset, and I only have so much time, and right now I'm focusing on this stuff. But yeah. Ashmek OP, I'm not exactly sure what you mean. Let's try that again. Close this because we're back to hanging these weights. We're almost done. And like as soon as these weights are done, like this thing's actually gonna be working. This is the last step, really. It's pretty cool. Let's put some music on. These playlists are not long enough on Epidemic Sound, but I have to be using Epidemic Sound because otherwise YouTube demonetizes me, and like gotta make money somehow. So this is a painting and drawing playlist. This is a funky, fantastical, and dreamy mix of tracks that will add color to your content. Cool. I definitely need a better system for this here. But it's working well enough, I guess, for now. Cool. That one does look like it's lower. No, that's actually good. So as you can see, all of the weights are at different heights now, and that's actually looking really sick. It's kind of got this wave pattern. So it's working the way that I want it to work, which is always a good sign. Anti-V games, I think, yeah, I need you to teach me some of your ways, dude. Because that's my biggest challenge. I need to get I need to get some more time in my life here. All right, let's see if we got enough pieces here to finish the job. I got 1, 2, 3, 4, 5 weights and 4 wedges. Beautiful. 5 weights, 5 wedges. So we should probably set this in the right position because it sucks to do things twice. It's another way to maybe turn the clock back, eh? Not mess it up the first time. Nobody's got time for mistakes. That's not true. Mistakes are important. Nobody got time for stupid mistakes. Beautiful. Next. Look at us. We're cruising now. not been drinking my coffee. I believe it was the Swiss who invented time, so we can blame them. I actually just heard today about like how like a little bit of the history of time in a podcast I was listening to. And it's actually, we forget about, this is an interesting tidbit. The hourglass and the mechanical clock were invented around the same time, which is interesting. And the hourglass was used for like small time increments, keeping time. And then that synced up. Everyone used like dead reckoning to sync up. 3 to go. Actually 4 to go. 3 after this one. But we're moving along. Look at that one. I got that one done so fast. But yeah, so they used to use dead reckoning where they would like just like try to keep track of how many times they flipped the hourglass over. And that actually kind of gave me an idea for a cool project to be get an hourglass, like a legitimate hourglass, and then like make a mechanism that like rotates it 180 degrees every hour, so it flips it, and like the sand dumps down. And then there's like going to be like an overall indicator that's based on a Geneva gear. And so every time it flips the hourglass 180 degrees, it ticks the total hour over, and then you get kind of an interesting clock. So yeah, stay tuned. Maybe one day I'll be working on that on live. That could be cool. But yeah, if anyone, is ever like wondering where ideas come from, they come from literally everywhere. And I've actually been thinking a lot about like how to like generate more ideas and like how to like be a better brainstormer. And I think it's really just like put something in your subconscious and trust it. Trust that your subconscious is going to keep thinking about things even when you're not consciously thinking about things. And that's kind of how it works. You gotta just stay open to it. All right, 2 to go. This is exciting. Time to find out if my engineering works. Oh, I almost screwed that one up. That's better. I don't really know if this is like funky. I guess it's funky, fantastical music. I don't know if you guys could even really hear it. I find my MacBook speakers really suck. So that's why I don't keep it too loud, because it kind of just like gets twangy. So Jamie, I do actually, in the next project that I'm going to be working on live and just in general is going to be a robotics project, and I'm going to be doing a lot of Arduino for that. Maybe not a lot, but there's going to be electronics in that project. Auntie V, I've got faith in you, man. You can figure it out. You can do it. But yeah, I actually am like moving forward. I'm probably gonna be doing less straight mechanical stuff because I've been really itching to like push forward my electronics and like mechatronics basically. Maybe one day I'll do some stuff with Raspberry Pi. I've actually never worked with it before. Raspberry Pi. So I look forward to like having an application that can use it. Probably gonna be something with like vision, incorporating vision. That's something that I don't know lots about, computer vision, but I would love to know more about. So yeah, if you have any good resources, let me know. But Arduino is like, I've been using Arduino for a long time, since I was in school. It's crazy to think how long that's existed for. But when I was in school, it just started coming out. All right, sweet. We're done. So I think I'm going to clip all these cables. But you can really see the wave. Look at that. Oh, that is so sick. Yeah, let's clip these and then we can turn some stuff. It's like the perfect music actually just came on for this. spring powered, eh? Like wind up kind of stuff. Is that what you mean? I've never used JavaScript really. I did briefly like try to learn like web stuff, and I think I learned JavaScript then. But no, I never really got into it. Like moving forward, I'm probably gonna spend most of my like development learning time on Python just because it's so versatile and like I don't know. It's so easy, and there's just like a really big community behind it, and like I find that's the best thing to look for when you're trying to learn like a new language. But yeah. Now we can get turned up in here. That's what this iced coffee is for, actually. As the kids would say. As the kid would say, getting lit. I feel like I'm too old to be saying stuff like that. Once you hit 30, you're not allowed to use words like lit anymore. I've tried, there's like this model in Thingiverse called like a tourbillon, or tourbillon, I don't know how to say it. I think it's a French word. But that's actually spring powered with 3D printed spring, which is actually quite cool. Okay, wow, that just came out of nowhere. It's time to give this thing some spins and see how it works. But actually, I want to make one last change before we do this. Sorry guys, just to keep you on your toes, but I want to make it faster. So to do that, we got to take this crank off. I've printed out the other crank. It's actually for the second iteration that we're going to put together next. But, okay. And then we need to get this out of here. It may or may not fit, we'll see. So it's just this like small crank here. This is the old one, this is the new one. But what I'm gonna do, you guys don't even see what I'm doing, my bad. So yeah, ANTV I actually did, that's the next iteration that we're gonna put together. And everyone, ANTV is the guy who suggested doing the articulating circle. And I think I'm gonna like the way that looks better, but I had to see this through. So that's why this is here the way it is. Okay, so this, it's not gonna fit. We can fix that. Should we fix that? We should probably fix that. Okay, it's not gonna work on this one. It will work on the next one, so let's, sorry about that. Keeping you guys sitting on Spilkus over here. We're just gonna put it back. We're gonna run this the slow way. And the next one's gonna be faster. Okay, sorry about that, everyone. The moment we've all been waiting for. How do I get you the best view of this? I'm gonna zoom out a little bit. Lift the camera up like this. Maybe turn it. There you go. Okay. So the main challenge with this is like I have to be really, really smooth when I'm spinning it. Otherwise they wiggle too much, but. So yeah, it's definitely a little too slow, but it's pretty sweet. Look at that. It would be cool to attach a drill. Or like an electric motor to it. Yeah, not bad. Something is, oh, it's getting stuck. Let's see. So one problem I think is that these, the weights aren't heavy enough. And if I were to print this again, I would probably print it with a higher infill to make them heavier. That would be pretty dope. Yeah, actually, I wouldn't even know right now how to implement that right off the bat. I guess that I've seen enough like wind-up toys to understand how they work, but yeah, it'd be cool to see this running automatically for sure. I think one of the reasons why I do everything with a crank is because I up to this point I've designed everything so it's all 3D printable pretty much, except for the string obviously in this case. But and then like people can download it and print it at home. But it definitely takes away some of the ability to do things like that, where like I like make it automatically powered. Okay, let's try it again. So everything looks like it's lined up properly. Try to stop everything from wiggling. Maybe we'll give you guys a different view, just for the fun of the perspective here. And here we go again. So what I really think I would need to do with this type of thing is actually make them all lined up, because it's kind of hard to see it in a circle form, I think. Or at least from the side. Maybe from this side is better. Thanks, Gabe. Appreciate it, man. How you doing? Long time. I'll give you this view last, and then we're going to get on to the next version, the suggested by ATV Games version. But yeah, it's pretty cool. It's I think if it was moving faster, it'd be better. I would have to print a whole new base in order to get this one to turn faster, but it's actually working quite well. I'll just crank faster. All right, yeah, sweet. Okay, so the next version that we're gonna do, iteration number 2, which hopefully will come together a lot faster because I'm halfway through my coffee now and I'm moving at a faster pace. Yeah, I think this definitely needed all 15 in order to get the effect that I was going for. But what we're gonna do is try the next iteration, which uses these escapement things. I actually only have single rows, so it's going to be more like this. And there's going to be 9 of these all the way around, and as it rotates, those are going to move up and down, kind of like this. And it's going to move faster, hopefully, as well. So I just need to print one last thing, which is these little wedges. But they should print quickly, so it's not a big deal. They're super tiny. So let me just pull them. These wedges, I think they're supposed to print this way. Boom. Let's make, we need 9 of them. Boom. You know, we're actually gonna do this, and then we're gonna make them closer together like that. Oh, I thought you guys were seeing what I was up to here. There, is that better? Okay, so we're just printing these. I'm gonna print them on the Prusa because it's the fastest machine that I have. And it should be 14 minutes. It's gonna probably be longer than that because it always is. Here you can see, if I turn you this way, you can see what I'm doing over here. If I turn this off and put this down. So we just gotta save it. And while that's saving, for some reason, if anyone can tell me why, because like I still haven't figured it out, why the Prusa parts take so much longer. Oh, that was quick and easy. Yeah, I agree with Mr. ATV. once you have something working once, it's definitely way easier to reuse it than to redesign. So I often reuse mechanisms that I've already designed. Okay. While that's printing, we're going to start assembling the next version. So we're going to set this to the side, and it won't take nearly as long because there's only 9 sections. So let's get all the parts for that. I'm actually going to readjust this because the legs are in my way. Beautiful. Okay, so I think what I'm going to do for this one, I'm going to do it this way. So first I'm going to put this into place. We're going to build the mechanism. I've got tons of C-clamps printed because I was running low on them. So this is actually a perfect example of reusing parts. Like I've used these C-clamps for a very long time. Tobias, I'm not using Octoprint. I probably should be, but I just never gotten around to making it work. And I guess the my system of just like using SD cards is like working well enough, but that's probably not a good excuse. I probably should be using Octoprint. Maybe that's something for a future Jay to figure out down the road. Just try to get everything running smoothly first. I'm just gonna make sure. Oh, we're gonna have problems there. Is what it is for now. Just get everything running smoothly, first and foremost. Put this in here. Okay, so you clamp that into place. Boom. Then we have our new handle. It's a little tight, which is like rare. Where did oh, it's because I printed this on the Anycubic, I guess. It's the challenge of having different printers. If it was up to me, I'd have all. Oh, it's so tight. It's never this tight. Did I do something wrong? Nope. It's going. What's going on here? Sometimes you need to file it. If you guys are 3D printing and you don't have a set of files, I recommend you get it right away. It's like $10 on Amazon. Yeah, definitely like, you know, like as someone who is like I use 3D printers quite a bit, I think Octoprint I'd actually benefit from it quite a bit as well, but that's yeah, I just like, it's so tight. The wedges, I've only ever used them for the first time on like what I was just using before. And it's only because I've never worked with string before, and I know it's really hard to tie knots on both ends at the exact right length. So that's why I decided to use the wedges there. This I might need to drill out, realistically. I must have done something. I don't know what it is. This is what the prototyping process is all about. And I'm trying to see if there's any like burrs or anything that I'm missing here, and there's not. So I don't really know what the problem is, but it's good enough. We're just gonna put it on and we're gonna rotate it a bunch of times until it's smooth. Oh my God, it's binding. It's so bindy. Why is it so bindy? Jeez, now it's stuck. All right, it's drill time. Here's another thing that was like one of my best ever investments. A metric drill set. So I need like 9.4. That solved my problems. It did solve my problems. Amazing. C-clamp, boom. It actually didn't really solve my problems. Maybe we should drill it to 0.5. Another thing that I've only in the last year really came to appreciate was WD-40 on this stuff. Yeah, the time lapses would be dope from Octoprint. Actually, I had my printer set up to do time lapses, but I was using the remote for my camera, and I had the Z-axis come and literally hit it at the end of every layer. It worked, but it's kind of a pain in the ass to set everything up. Oh yeah, power tools to the rescue. There we go. Look at that. Now it's spinning the way it should be. C-clamp. Good to go. Okay, back to where we were. Let's just get some of this stuff out of the way. I really have a tendency to not clean up after myself, and I'm trying to fix that, so. Put these back to where I got them from. Put my drill back to right here. Grab another sip of coffee. Back to work. So this goes here. Oh no. No. I forgot to make this hole the size I need it to be. Okay. First we're gonna make that change on CAD so I don't forget it. Moving forward. And then we're gonna figure out how to prototype. It's the worst when you screw up a piece like this. Okay, so it's this hole right here. So let's just isolate this first and figure out what size we need it to be. This is 10. So we need, it's not this guy, it's this. Isolate. We need this, which is 9.4 to be 10.4. Oh, oops. 10.4. Okay. Now we will never make that mistake again. The problem is with my drill bits, I only have up to 10 millimeters. I wish I had up to 12 because the times, it's just like the amount of times that I run into this problem where I need a 10 millimeter, a larger than 10 millimeter hole. Okay, I'm just gonna drill it and do the drill wiggle technique and hope that works. And if it doesn't, it's gonna be a drill and some filing. But 10 millimeter drill bit. Let's just see, maybe if we're lucky. No. So I'm trying to decide. So it's interesting. This right here is a 10 millimeter shaft, but when I measure with the calipers, and this is something to keep in mind whenever you're designing for 3D printing, it measures at like 10.1. Some places are like 9.89. This was printed on my Anycubic. It's not the most precise machine, but many people have like Ender 3s or like, you know, like less precise machines than a Prusa. And I'm saying that, but I'm actually curious. I don't have any Prusa printed parts with me right now. But yeah, so like that, you can see like it's some places it's 10, like less than 10, some places more than 10. So that's why I always have a clearance on holes of 0.4. In this case, just try to do the wiggle technique with the drill. The old driver's license. Perfect desk cleaning tool. Alright, let's see if that solved my problems here. No, it's tight. It's still too tight. So I was actually trying to decide, do I file this hole out, or I have another idea, which I think might just overall be a little bit more satisfying. I'm going to clamp this end in the drill. And then I'm going to try to file this down. And hopefully that works. I think I need to file this. Doing something. It's still a little too hard to crank. It's not terrible actually. Surprisingly not as bad as I thought it would be. I think to finish this off, I'm going to file the inside of this hole out a little bit more as well. And this is really like this is the whole process of prototyping, is like often I try to move quickly and that leads to mistakes, little mistakes like this, that take such a large amount of time to just like fix. So like really the best thing I could do if we weren't on live is I'd probably just reprint this for the sake of this test with a smaller shaft here, and then I already made the changes on the CAD, which is good. But yeah, so we're done with the redesigning, so now we're just trying to assemble it, and I ran into a problem here where I made this hole a little too small, but it seems to be working better now, and I'm gonna just throw like a little bit of WD-40 in there, and hopefully that solves the problem for us completely. But otherwise, this should work, and if it doesn't, good enough for the sake of this test. Absolute Chaos, welcome buddy. I appreciate you coming into the stream here. So yeah, good enough at least to test the concept here, and we can fix this later. Okay, let's keep moving. Sweet. So next thing we're gonna do is I already tied the strings on this piece because like that is like excruciatingly painful to watch. So we're gonna throw that in there, and like you've seen me do this before, but the nice thing is this time around, I can just do it like this. Where I'm gonna run the cable cable, using that word again, fishing line through the segment, and then I'm gonna put it into place. Boom, look at that. So I fixed the tolerance on the base, so these are a lot more sturdy than on the first version. That was a good change. And this is gonna make life so much easier. Look at how much faster we can move here. That is actually like, honestly, like a problem that I do all the time. Is like you just change, oh, like that. It's way less tight. Sweet, so those are now, the wedges are now done printing, which is great. I'm trying to decide if I want to print a new handle. Nah, for now it's good enough. Okay, let's just carry on with what we're doing here. Got some nice smooth jazz in the background, keep us going. Yeah, so I know you were here yesterday, so you saw they're a little bit wiggly. These are way better and a lot more satisfying to pop in. Boom. Look at that, it's not going anywhere. This one's a little bit loose, but the only problem is when they're this sturdy, if I make a mistake, it's really a lot harder for me to undo it. But for the final version, this is the kind of fit that we want. And I can actually show you guys, so like the way that this works. Here, let me show you guys what's going on inside under the hood here. So each one of these, here, if I do this, show that, no, not this. I need to show this trunk section. And we can grab a cross section on this plane, and you can see right here what's going on. So there's these little ring things here, and then when I hide that, you can see there's like little indents on the base, and that's what these ring things jump into. What is a fipple? I've never heard of this fipple before. Maybe it's because I'm Canadian, who knows? So there's a very important distinction between this version, and it's not the number of segments here. The distinction is the wave that's going up and down. It's not weights. It's going to be an articulating ring. This was inspired by suggestion yesterday by Mr. Anti-V Games. It was his idea, and it may or may not be the way we go moving forward when this is on the website, but at the same time, I'm honestly like not really sure how I feel about this project as a download file. It's kind of hard to assemble, so it may just live as a Instagram thing. Absolute chaos. What I'm making is, let me pull the first version out so I can show for anyone who didn't see it. This is it right here. And a lot of people are asking me what it does. It is a kinetic sculpture that has some sort of representation of life. And I'll let you guys come up with the understanding, or let you come up with the interpretation. I can make up a lot of things, but this is it right here. So I created a second version based on a suggestion. Gabe, it's not too late. It's never too late to learn something like that. It's actually easier to learn now because there's so many resources online. So yeah, if you want to learn it. But I would recommend not learning AutoCAD. I recommend learning like one of the AutoCAD's pretty outdated at this point. Like pick a good free CAD package and learn that, or Blender's a really awesome thing, a really awesome skill to have. So I was working in the toy industry before I was doing this, and people who could do 3D sculpting was like a really hard to come by skill set. So if you're a 3D sculptor, you're actually you could probably find some work in the toy industry pretty easily. And that's something you can use Blender for, or Maya, or there's other software. Okay, so that's done like that. So now we have this top piece right here. It's a little bit stringy. It's definitely a lot easier to work with these like 9 cables than it is with those 15, but okay, we gotta get this into place now. All right. Come on. Why doesn't it want to go? That's frustrating. There you go, Sine. That's exactly what I'm talking about. That's a perfect explanation. It's just a metaphor. All right. There we go. Sweet. And yeah, ATV games like AutoCAD. Yeah, I learned AutoCAD in high school, and yeah, it was definitely outdated even back then. Actually, it's funny, now that I think about it, they taught us AutoCAD in first year of engineering school as well, as like an introduction to CAD, which is kind of funny. Gabe, I definitely will, and I definitely will need a custom PCB in the future, so I'll keep that in mind. Let me know if you ever need something 3D printed. Mrs. B, I wouldn't call myself that smart. It's more just I've accumulated skills over a long time. This is really just an accumulation of experience. Okay. So we're almost done these strings. This is way less painful than the first ones, eh? First ones took forever. And then we can assemble the articulating. So I actually have no idea if this articulating wave system is going to work, but we can try. Okay, let's grab it. Might as well work out of the box because everything's in there already. So the way it works is these pieces go into these pieces here, and I'm going to just like file them out a little bit. I was trying to figure out a good way to print these, and there's just really no good way to do it. Tomas, I didn't remove the weights. This is just like a second version where I'm trying something different. Okay, I'll take it. Fine. I'll take it, Chaos. But yeah, Tomas, I'm just testing out a second version to see which one I like more. So yesterday, I ended the stream. I had only done 9 weights, and like they're kind of like sporadic. And I really didn't like the way it looked. But having seen it now with all 15 in there, I actually really do like the way it looks. But Anti-V Game suggested yesterday after the stream that I do it as an articulating wave segment, and I thought that could actually look really cool, so I decided to give it a try. And that's all we're doing. But this is just it's like, you know, it's V1. It's not even V2. This is just like alternative V1. Although I did call it V2. But yeah, so I was saying just before, like, I really couldn't figure out a good way to print these without support. So that's why, like, I printed them in this orientation, and when the printer comes across here, it, like, some of the filament droops. And that's what I'm just cleaning up right now. You can see, like, come on, it's not the cleanest inside there, so I'm just trying to flatten it so these segments can move more freely in there. There's definitely limits to what 3D printing can do. It can do a lot, but that's also definitely true, Kenny. It's worth a thought. Honestly, though, at this point, I'm pretty happy with the way the weights turned out. So I think what I would do is just put the weights on a single crank, take away that, and maybe that's how I'm going to call it as the project. Because I'm definitely ready to move on to the next one. This was like a really basic idea I had that, like, as always, like, supposed to be like a 2-day project, and turned out to be like, I've been working on this for like a week now. And it's always the way it goes, but once you start something, at least what I've been trying to do lately is, once I start something, I try to finish it. Okay, so the way this works is these go in here. You C-clamp them into place like this. And then you just repeat that all the way around. Boom. So I'm just going to keep going with that. Make sure that these gaps, these are the gaps right here for the wedges, using the same approach as before. And I'm not really sure how this is going to work, so we're going to find out together. Feeling this tune right here. Yeah, it'd be hard to bend them to the exact angles though. This is exactly 40 degrees from this one to this one, or like 140 degrees like this from here to here. And that means like it'll be perfect 9. So it would be really hard to bend them to like the right angles. And also, like, keep in mind, like, when I design this stuff, I design it for like anyone to be able to put together themselves, so like print and put together themselves. So that factors in with literally everything that I do on projects like this. So I wouldn't be able to like suggest to someone to like try really hard to get bent to the right angle. I think that's just like a little too vague, which is why I'm trying it this way. Yeah, these pieces you might just have to print with support. There might be no way around it. Or I might have to make the holes just a little bit bigger so the droop doesn't get in the way. Which is fine, because like they need to have some room to move around. And so actually it could be fine to get a little bit of droop going. So just so you guys know, before I did this full commit on the 9, I actually did a 5er. I tested the way that this works. This was just so I only have to print 5 of each thing. But unfortunately, I can't reuse these pieces because when you use 5, it's a different angle from when you use 9. As you can see, it's a little bit more of a steep angle. Boom. 2 more. And then we're going to have to figure out how we're going to hang this thing. Last one. Tip. All right, let's see if this is gonna work. I don't know. What do you guys have any money on this? Is it gonna work? Is it not gonna work? What are your percentages? I'm gonna give it like a, I don't know, 80% chance of working. No, 60% chance of working. Got our wedges. Try not to lose any. Okay, and so basically it's the same process at this point. We're gonna get this to a position. And then we're gonna start with this one here. And it's the same tool. Honestly, I probably should have hung these before I built it, eh? Live and learn. We'll see. I might have to take it apart. Just got carried away. I really wanted to put the articulating parts together. Okay, so we all know this process now. Done it a few times. The moment, well, it's the 9 moments that we have been waiting for. So this one change I did on these was I put a little groove at the bottom. Oh, I should have made the groove bigger. If you can see, like there's like a tiny, tiny groove there. If I made the groove bigger, it probably wouldn't jump away from me like that, but. Okay. It's a new learning process here. Yeah, seriously, it's the fun part. I like decided last minute to make this tool last night, like right before I went to bed. So it can definitely be improved. I was just trying to get it done. All right, there you go. Not bad. That's one down. We're gonna do this one next. Boom. Yeah. All right, it's working. I feel like I've gotten better at this whole process here. Now that I've done it 15 plus 2 times, 17. That's 15 plus 2. Got to think about how I can improve it though. I need to improve this like the way that this piece holds the wedge, so I can, you know what, that's actually not bad. The groove is actually helping. I think we're moving faster than we were before. Could just be that I'm getting better at it too. Very, very possible. Feeling this vibe here. Yeah. All right, this is going smoothly so far. The only problem is this. This isn't very smooth, but thanks, man. I'm happy that you feel that way. Like, it's fun for me to be able to share with you guys, and the fact that you guys are interested in seeing it come together and seeing how it looks. It's a lot of fun to do this on live with you guys watching. You know, making mistakes, all of that fun stuff. It's a lot more fun to do it as a chill than completely by myself. This was actually like one of my original goals when I started doing this, was to do this all on live, but I wasn't really sure how to do it, and you know, like I was a little bit more awkward than I am now. But I've spent a lot of time learning how to talk to a camera, and yeah, like I wasn't sure if I'd have enough to say, but like, you know, it's nice. It's like nice to have you guys like interacting with me, asking me questions. It makes it a lot more fun than doing it just on my own. And it's also motivating. You guys are motivating me to keep going. So I really appreciate it. And it's 2 o'clock now, but we're gonna keep going until we're done. This is like, we're so close here. Don't know if this is gonna work, guys. The articulated wave. Not feeling confident about it right now. But that's all part of it, the process here. You know what? I don't know if I'm really, this isn't really slowing me down. There's definitely pressure, but like Kat, I'm just like, luckily I'm so comfortable with it. So, yeah. Tomas, see ya, buddy. Thank you so much for joining. I really appreciate it. It's been a good time. But yeah, it's, you know, the pressure actually, it's like when I don't know how to do something, then it's a lot harder to do it with people watching, like trying to figure out like the math or something, but you know, it just is what it is. So this is, okay, last one, and then we'll be able to figure out if this is gonna work or not. My prediction's actually gone down now to, I don't know. Oh, how did I make so many wedges? It's often that I don't make enough, not too many. Yeah, my prediction is it's kind of dropping right now. I don't think these parts are articulating well enough, but hey, we'll see. I could be surprised. They might just need to be heavier, in which case I'm actually going to turn on my glue gun. Because if it's not working, I have an idea to make it work. So, unfortunately, I can't start the stream any earlier. It's like, right now, it's 12 o'clock right now it's 2 o'clock in the daytime for me. And I need those like few hours in the morning to get prepared, get everything ready to go, reprint parts that failed or something like that. So yeah, I wish that I could do it for you, buddy, but unfortunately I can't. Where are you located? Are you in Europe? Okay. So let's get everything lined up. Let's clip some cables. Yeah, so one problem that I'm seeing, you can actually see the wave, which is cool. The one problem is that maybe these aren't heavy enough. If they're heavier, maybe it would be better. Okay, let's clip the excess string here. And then because it's not heavy enough, I'm gonna glue some ball bearings to these pieces to get it to be heavier. I can really prove the concept. Although I think right now I'm leaning towards weights. So, okay, yeah, it's a little late. That's kind of my normal bedtime. Miss B, you must be somewhere west of me. ATV, I guess you're in Europe. But yeah, India, it's definitely, it's pretty far away from here. Different time zones. Okay. Boom. So you can actually see the wave, which is cool. Let's see what happens when we rotate it. So what I'm actually going to do is I'm going to WD-40 that first. Just to try to get it to be a little smoother. Get in there, WD. Oh, wow. It's amazing how big of a difference WD-40 makes. Okay, so look at that. It's actually working. That's dope. I still think it needs to be heavier. So let's glue some ball bearings to the bottom of each of these weights, just for the sake of the prototype. Right, Belgium. Just need to find a good place to plug in my glue gun. Don't have any good places here. It's okay, we'll just work fast. So I got some ball bearings here. I'm going to glue them onto the bottom of each of these pieces right here. Nashville, Tennessee is a great city. Been there a couple times. A lot of fun. You have that one main street in the downtown. It's a huge party. Live music everywhere. I love it. This may or may not hold, but this is the main reason I was thinking about doing the double. I'll show you that in the CAD next after I'm done doing this. Just focusing here, guys. My glue gun's running out of heat. Just gotta do some quick gluing moves here. Luckily, when you glue something into a ball bearing, it just absorbs the heat so fast that the glue cools down like instantly. Which is really nice when you're trying to move fast. All right, sweet. Okay, the grand finale. Absolute chaos. Are you referring to what are you referring to? I can try to explain it better. Let's get everything lined up again. It's funny, when I actually mentioned to, when I built the prototype, I showed it to my buddy, he said Squid Games just because of the marbles. So there it is. Okay, so let's just see how there's... Ah, true. Okay, so here it goes. Oh, this crank is it's ruining my day here. So here's a problem right here. Like, see how it's twisting like this? Once these are free to twist, though. What's up, Neptune? What up from Texas? What up from Toronto? Right back at you. Squid Games was a crazy show, eh? Awesome. This looks more like an amusement park ride than the other one. Okay, so there we go. Now we're turning. Let me get some more WD-40 up in here. Beautiful. Not bad. Okay, so it's time for you guys to tell me what you think. Let's just get everything cleaned up here and we can do the final comparison. Get rid of this. So, Exhibit A, articulating linkage structure. Pretty cool. Might actually even look cooler with the double. Might look really sick. Okay, actually what I'm going to do before we finish this. So these rubber feet are the most clutch thing. Just put them on the bottom here. Yeah, it's true. I think we all just wanted to see him get on the plane and go visit his daughter. Sorry, if there's any... Oh, I didn't realize that I could be spoiling it for someone. So, I apologize for that, guys. But yeah, I think we all wanted to see... I'm going to work on not spoiling things in future streams. I really apologize if anyone's watching it currently or planning to watch it. But yeah, the ending was definitely not perfectly satisfying. Okay, so you got the ring. Anti-V is on board with the ring. I think a double could be really sick. Actually, this is quite interesting looking. But it's a little bit less, I don't know. Oh, shoot. See what I did here? I accidentally crossed strings here. I'm gonna fix that quickly. That's why I left a little bit of slack. How did that? Oh, I just wrapped it. Okay, it's easy fix. Better. That's better. Now I gotta just get it into the right position. Thank you, Miss V. You know, for me, the spoilers, like, it's more just that, like, I'm always, like, once I hear something, like, I'm just, like, now anticipating it for the whole show, that it, like, ruins my ability to take in, like, the current part where the show is at. That's where the spoilers get me. This is tricky without the extra slack. There we go. Okay. So, let's see. Once this loosens up a little bit, maybe it will be better. Yeah, so the double, let me show you what it looks like in the CAD at least. I've only did one segment, but... Boom. So that's kind of what the double would look like. And I think that would look pretty sick. So yeah, maybe we'll throw it down. But honestly, at this point, I don't know. I haven't decided which way we're gonna go. But there's one thing to be said for sure about this gear ratio, though. Eh? Faster is definitely better. Okay, so this is Exhibit A. Yeah, I think that would actually, as a double, that would look really awesome. Cool. And then Exhibit B. Let me pull Exhibit B out and put them side by side, and we can look at them. This would probably look better in line, I think. This looks cool like this. This is also a problem. They just wiggle way too much. Way too much wiggle. So if we look at them like this, side by side. Wow, a double ring that goes opposite of each other. You're saying these remind you of adult toys? I guess I could see it. So, everyone's got their interpretation. I thought they kind of looked a little bit like bombs or bullets. Someone mentioned earlier they look like acorns. Neptune, we know where your head's at. But yeah, so this is, okay, hold on. Let me get my face out of the way here. Put it here. Lift this up. I definitely think it's better when they move faster, so it's not bad though. All right, Neptune calls. Is this is Exhibit A, right? The ring. Yeah, I think Exhibit A is way cooler as well. Exhibit A, Exhibit B. So for Neptune's idea to have two articulating rings that are working in opposite directions, yeah, I don't think we're gonna go there right now. Okay, so the jury is spoken. Exhibit A is the way we're gonna go. So basically at this point, what I'm gonna do is probably design the double ring and then finalize it and figure out how we can print it in a way that it will print. And then basically tomorrow it's gonna be like, you're gonna see the final version. And I'm gonna go through the process with you guys of how to set this all up as an STL, upload it to my website, all that stuff. But for now, I think we have an awesome prototype. This is an awesome prototype. And then we have this, we're not gonna go with this, but it's an awesome secondary sculpture. Exhibit A, exactly. You got it. You got it. Or you even say like, oh, so you guys like Exhibit A, eh? Lots of A's. But yeah, thank you guys so much for hanging out today. I really appreciate it. I don't think they do. So I'm actually that's gonna be something that I change as well. I'm gonna make these holes bigger. Make everything a little bit looser. Yeah, it could be a chain of rings, could be cool as well. But I like them being like these linkages. I'm the engineer, and as the engineer, I'm gonna call it I'm gonna call this basically a project because I'm happy with the way this looks. We're gonna go with the good enough approach because I'm ready to move on to the next project. Yeah. Okay. Before I go, do you have any suggestions for me in the comments? "3D printed chainmail, eh? That could be interesting as well." I like the links though. I do like the links, so I might stick with the links. But I think we're gonna do the double links, or maybe even double. We're gonna do double for the sake of just like parts, because like if someone's printing this themselves, I don't want them to have to like go nuts printing links. But yeah, we'll double it up and see how that looks. So tomorrow, come back, you'll see everything basically in its final form and ready to be put onto the internet for anyone to download and build themselves if they're feeling crazy. Or if they're just interested in like doing something fun, artistic, gets you in a little bit of a flow state. So it's all good stuff. Thank you guys so much for hanging with me today. I'm exhausted, but it's been great chatting with you guys, and it's been great getting your input on this stuff because this has been definitely the most interactive lab that I've done so far, and it's a lot of fun. So I hope you guys come back out, and yeah, keep thinking about those ideas. If you have any more ideas, put them in the comments. The video will be up, and I would love to hear them. Yeah, so enjoy the rest of your day, everyone. And Miss B, maybe one day there will be a theme park, roller coaster tycoon. All right, peace out, guys.